Hey now.
Hey.
So we're doing a Monday night science fair project.
Random, I know.
But we're not in school. It should be fun.
So what we are making today is called polyurethane foam. You see that foam everywhere. It's in your shoes, it's in the seat cushions, it's everywhere around us. So we're gonna do that and learn all about chemical changes in the process. So one way you know that chemical changes occur is how?
The smell, the texture, the color.
Good.
And you cannot take it back to its original state.
Very good, very good. So unlike paper, if I just ripped it in half, it would still be paper, nothing new. But if I actually burn the paper, I can't get the paper back, definitely not new. So in this chemical change that we're gonna be doing, we're gonna be looking for signs that a chemical change has occurred, all right? So in this cup, all right, hold that. If you could describe that cup, how would you describe that to me? What would you say about that?
It's lightweight. Liquid.
Liquid, okay.
Can you see it shake?
Can you see through it?
You can see through it. A little thick, but you can see
So
through it.
viscous, right? And transparent. Fill the cup. Is it hot, cold, or room temperature?
Feels room temperature-ish.
Room temperature is cold in here, so it's probably but it's all good. So that right there, that's what's called a polyol. So a polyol is something that has a long series of carbons. At the end, there's some oxygen and hydrogen. And that long series of carbons is going to be very, very flexible. And those oxygens and hydrogens at the end, if we can cleave that off, we can actually use those as a clasp, if you will, to like close a necklace.
Okay.
So the carbon is going to be very, very, the carbon chain is going to be very flexible. And we're going to try to clasp it to something. Okay. So now our next compound is an isocyanate compound. So this compound, if you could describe this, how would you describe this?
This is thick, like syrup.
Like molasses.
Molasses.
Yeah. And let me pour a little in a cup so you can see through it.
It's not, you can't see through it like with this cup.
Just put a little in here.
Yeah, it looks just like syrup. Don't put this on your pancakes.
That ain't what you want. That ain't what you want at all.
So it's still clear. No smell. Just darker.
Okay. And so I want you to go ahead and pour this and try to get it so it's about the same amount. You're pouring about equal amounts of this. So pour this one into that one.
But if my daughter is gonna get covered for everything that she needs, there's like.
And so what she's pouring, that's an isocyanate compound. So there's a ring in the center, and there's some nitrogen and oxygen on the ends. And that ring is going to add more rigid features to this foam that we're going to be creating. So we're going to be clasping the two together, this compound and this compound, this and this, to form a polymer. Okay?
Am I done?
Yep, you're good. All right, so now put that down. Hold the cup up and kind of describe what you're seeing.
So it looks like a separation of liquids.
Okay.
But it looks like the liquids are being drawn. Like it looks like a pulling down of a liquid.
All right. So have you seen kind of this separation happen before, like maybe with
Water and oil.
Perfect. So why don't water and oil separate? Well, a big reason is why. Do you know why?
Because of the weight.
So part of it is weight, part of it is the density of it, but the other part is their polarity. So polarity means that their electrons are shifted to one side, whereas the oil is nonpolar. And they're not shifted. So nonpolar and polar don't really want to be around each other. So these two things actually don't really want to be around each other. One, because they're different polarities, and two, because of the density. Now, if you look closely, you can start seeing a little something forming. To kind of describe what you see there.
Looks like bubbles.
All right.
Forming like
some bubbling.
Yeah,
but
bubbles.
Pretty slow, right?
Oh yeah.
All right, so we want to go fast.
Okay.
So we got to add something to this reaction.
Okay.
So something we can add to a reaction that makes it go faster but doesn't get consumed by the reaction is what's called a catalyst.
Okay.
All right? So a catalyst can be a chemical thing, or it could also be a mechanical thing.
Okay.
In this case, you are going to be the mechanical catalyst.
Okay.
All right, so what I need you to do, you're going to need to stir about 100 times, okay? And the more energy you put in, the more bonds you're going to be able to break. The more bonds you break, the more bonds you can make. The more bonds you make, the more oxygen is released, the more that can get trapped in your big polymer, okay? So once you start stirring, I'll tell you when to stop, so stir.
And this is just a popsicle
Just a popsicle stick.
Okay, ready?
All right, stir as fast as you can. Fast. And start describing kind of what you see.
It's turning colors.
All right, keep going.
It's
faster.
getting thicker, almost looks like glue.
Faster. About 100 times, you got to break all those bonds.
Breaking bonds. Where's my arms out?
Keep going. You got to break them all up. We're making all these links here. Keep going. Faster.
It's getting bigger.
All right. Now stop stirring. All right. And I want you to just keep the popsicle stick here. Hold the popsicle stick here. Hold
Look,
it.
guys. It's growing. It's alive.
All right, I want you also to feel the cup real quick, just kind of on the sides.
Oh, it's warmed up.
All right, it's warm. So that's what's called an exothermic reaction. So heat is actually being released from this. So we're going to try to keep this up nice and tall to guide it up. And you can also see, what do you see forming in the foam here?
Ridges.
And if you can look close, there's also some little bubbles.
Bubbles,
right?
and it's hot.
All right, so that is, again, an exothermic reaction, meaning heat is exiting the reaction.
Y'all see this?
All right, so remember, we started with 2 little bitty liquids. Now, in a few seconds, we now have
Solid as a
material.
rock.
So this is an example of a chemical reaction because we cannot reverse it back to this. We also saw bubbling. We also feel the heat.
It is
You
hot.
smell a bit of an odor?
Slight.
Slight odor. Again, just like when you're cooking, that's how you know food is done, because of that odor that's being formed. So that's something new being formed. So you are now officially a chemist.
Yay!
Hey.